Let's consider this box to be the computer memory. It's divided into cells. These memory cells, they each have an address linked to them. The way we access each cell is by knowing the address or referencing that address. Let's take an example of an array. An array is called ARR. When I access the first index, say ARR of 0, that will be replaced with the address, let's say 01, and that's how we access the data in there. If we want to access ARR of 3, all we have to do is to add the index 3 to the beginning address of ARR 0. If we go back, it's 1, so 3 plus 1 is actually 4, and this is the address of ARR of 3, and that's how we access it. This is a feature that gives us the random access basically in the array. However, computer memory is not as clean as that, especially if you run after programs in the operating system. So things are more likely to look like this. And in this case, there are wasted spaces in the middle. Obviously, we cannot put an array there because they have to be in adjacent places. So what we can do is we can actually take advantage of these spaces and use them, for example, in a linked list. Linked lists or data structure consists of multiple nodes. So let's take this simple node as an example to start with. So the node has two parts mainly. One has the data, and it could be mixed data, it could be multiple things or multiple variables, and there's a pointer or a reference. So this node is basically an abstraction of data. In C programming language is struct. In Java it's a class, for example. So what we're going to do with this is that let's say this is somewhere in the memory. How we're going to access this node in the memory is by knowing its address. So to do so, we're going to save that address into a pointer or into a reference. So let's call that to be first, for example. So first is a reference or a pointer to that node that we created, and we will see the code of that node or first later on. Now this node does not have a name. The only way to access it is by knowing its address. Therefore, when creating that node, I'm going to take that address, I'm going to put it into the first pointer so I can basically reference to it, or I can point to it so I don't lose it in the memory. So if we do that, we have the first is pointing to node, and similarly we'll be building other nodes. But first, let's put some data in there. Now we can access this node by pointing to it. Then we can access what's inside the node and we can fill in the data. So let's say we put number 13 as an integer, and then we put null as a pointer. Null in this case, it means that it's not pointing to anything. We can also replace the word null with this symbol, and usually it means there's a null pointer in there and it's not pointing to anything. So let's create another node, let's say, and now again, the only time we know the address of a node is when actually creating it. So we create this new node and we have the address of it, so we don't want to lose it in the memory. We want to store that address somewhere. We're going to store it in this previous node where the null is. So now we can actually use that pointer, so it's pointing to this data or linking the second node to the first. Since we are accessing already, we can also put data in there. So now we can say let's say number 15 instead of the data integer, and null as the pointer. If we want to add one more node, we can repeat the process. So let's go ahead, create a node. So now we know the new node address. We put it in the previous node pointer, or we reference to it in there. So now it's pointing to the next one. We have access to it. We can put data. Let's say we put number 19 as an integer, and we continue this process. So this is an example of what a linked list looks like. It's basically a bunch of nodes. These nodes do not have names. All they have is addresses, and the way to access them in the memory and to know where they are and to get into the data inside them is by knowing their address or their reference. Each address is stored in the node before it. Therefore, to access or to go through this entire linked list, it's something called we traverse through this linked list is going through it, is by accessing the first node. So we have that address in what we created or called first. And from the first node, we can access the memory address of the second node. And from the second node, we can access the memory address of the third node. And we continue like that until we access the third node. This is the only way to go through the linked list. Clearly, this does not have a random access.